Hello Kusto community, my name is Ryan Majitimer and I'm a product manager on the Azure Synapse Analytics team. Today I'm joined by Henning Rauch, who's a principal product manager on the Azure Data Explorer team for this episode of the Azure Data Explorer 101 series. Today we're going to talk about doing geospatial queries with ADX at scale. Gonna hand it over to Henning. Welcome.
Hey Ryan, thanks for having me in this episode. Telemetry data is everywhere. Smart, connected devices are in our homes, buildings, factories, and in the devices critical to consumers and businesses. A big portion of it has geospatial information, such as latitude and longitude. So, we decided to add geospatial functions to our query language, KQL. We implemented 40 functions, and the number is continuously growing. A big focus of our development is on providing geospatial clustering algorithms. They allow you to aggregate big amounts of data to efficiently calculate KPIs on large areas. Finally, we offer our customers an experience to visualize their geospatial data in our Kusto Web Explorer and dashboard experience. Having those capabilities, you can implement interesting use cases like fleet management, geofencing, and supply chain management. Let's dive right into it. Let's start with documentation. First, we kick it off with a geospatial clustering documentation page where we are comparing all of the methods that we are implementing, such as GeoHash, S2Cell, and H3Cell. The next section is covering geospatial visualizations with the help of Kusto Explorer and Kusto Web Explorer. As always, you can use the render operator to visualize your data on a map. Next, you see all of those 40 functions. I'm not going to go through all of them. We can click on a single one, like point to H3Cell, where we're taking as an input the longitude and the latitude of a point, the resolution that we need for the H3Cell, and as an output we get the H3Cell, which we can use to do further analytics. Next, let's have a look at a couple of samples. I connected to the help cluster and I'm using Kusto Web Explorer. The first example is calculating the distance between two cities in Germany. One is Stuttgart, the other one is Munich. You see I'm using the function geodistance 2 points, and if I execute it, I get back it's 190 kilometers. My next example intends to find events which are near to a line string. We are using the geodistance point-to-line function to calculate the shortest distance between a coordinate and a line or multi-line on Earth. In line 15, we are filtering the storm events table to return events that were closer than 500 meters to the road to Key West. Line 16 is rendering the result as a scatter chart map. Let's execute it. As you can see, events relatively close to the road to Key West were found. For example, one, the thunderstorm wind, another one, a waterspout. This one is a waterspout, or a thunderstorm wind. Let's talk about geospatial clustering. Geospatial data can be analyzed efficiently using grid systems to create geospatial clusters. You can use this technique to aggregate, cluster, partition, reduce, join, and index geospatial data. In the first phase of the following example, we are filtering the storm events table to a specific area which is described by a circle. This is happening in line 21. The following line summarizes the count by event type and geospatial cluster. In this case, we are using a S2Cell. Then, line 23 is calculating the center of the cell because we want to render the result on a map in line 24. The bigger the circles, the higher the count of specific event types in an S2Cell. In our next example, we are going to cover a scenario where we are defining an interesting area by a polygon to filter events and execute time series analytics on them. First, We need to find the interesting polygon in line 27 to 31. Therefore, we filtered the US states table for GeoJSON dynamics with the property name and value Texas. Once we found it, we are calculating the S2 cells which cover its polygon. The next part of the statement is extending the columns of the storm events table with an S2 cell of the same size and executing a coarse grain filter in line 36. This helps reducing the input for the geopoint and polygon function, which is shown in line 37. In the final phase of the statement, we are entering the time series world and try to find anomalies in the damage caused and render the result in an anomaly chart. As you can see, we are able to find a couple of anomalies. Here, here, and here. Now, we all know that KQL is fun to work with. The last statement underlines that. We are drawing the word Kusto on a map. The last part of this video is about a use case that was implemented recently using Azure Data Explorer, Safety Data, and Azure Maps. What you see on this map is events that were clustered and aggregated by H3 cells to visualize overspeeding and dangerous locations. H3 cells are oftentimes preferred over other grid systems because they render really nicely. Let's zoom into the data. See the nice shape of the H3 cells. You can also click on it and see, for example, safety events on this H3 cell. The rendering of this visualization was implemented using Azure Maps. That's all that I wanted to show to you today. Thank you very much for watching this video. Back to you, Ryan.
Well, that wraps up our video for today. Thanks, Henning, for joining us. Tell us in the comments, do you geospatial query? I'd like to hear about it. Again, my name is Ryan Majitimer. You can find me on Twitter. You can find Henning on Twitter, Cosh23, COSH23. You can also find Azure Data Explorer on Twitter, AZ Data Explorer. Like, comment, subscribe. Thanks for watching, and we'll catch you on the next one.